Hi ladies, in this video we're going to go through the more difficult questions from 6D. So let's just scroll up to refresh our memory of what index laws are covered in 6D. So index law 4, so when we're multiplying within the bracket, everything inside the bracket is taken to the power of m. Okay, so that's when we're multiplying. So not adding or subtracting, just multiplying. And when we're dividing, or if it's written as a fraction as it is here, the numerator and the denominator is also taken to the power of m, as you can see. Okay, so let's have a look at question 6. So the rule for the number of seeds germinating in a glasshouse over a 2-week period is given by n equals t over 2 to the power of 3, where n is the number of germinating seeds and t is the number of days. So question A, find the number of germinating seeds after 4 days and 10 days. So we're just substituting in for t. Okay, let me just get my pen ready. So our equation is n equals t over 2 to the power of 3. So question A, part 1, we've got 4 days. So that means that t is equal to 4. So we're just substituting that into our equation. So 4 over 2 to the power of 3 gives us 2 to the power of 3, which is 8. Okay, so 8 seeds. 10 days, the same thing. We're just doing a substitution. So part 2, we're going to have t equals 10. So I've got n equals 10 over 2 to the power of 3 equals, so you don't have to do 10 to the power of 3 over 2 to the power of 3. You can simplify this first. So 10 over 2 is 5 to the power of 3. You're going to get the same answer. It's just probably more complicated to do it that way. All right, so 5 to the power of 3, we have 5 times 5, which is 25. And then times 5 again gives you 125. So if you needed to use your calculator for this, you can. All right, so question B, use index law 5 to rewrite the rule without brackets. So let's just write that down. So our rule is n equals t over 2 cubed. So we're going to get rid of this bracket. So remember, we take the numerator to that power, so t to the power of 3 and 2 to the power of 3. So it's going to be t cubed over 8. Now you can see that would make it more complicated, as I said in this previous one, because then you're going to do 10 cubed, which is 1,000, and then 1,000 divided by 8, which gives you 125. Okay, so sometimes easier not to expand your brackets. Use your rule in part B to find the number of seeds germinating. Okay, so let's just go back. Okay, so 6 days, so t equals 6. Now it did say it wanted us to use this other rule, so n equals t cubed over 8. So 6 cubed over 8. 6 cubed, 6 times 6 is 36, times 6 again, oh my gosh. I'm going to have to do it on my calculator just because I don't want to get the wrong answer. So 6 times 6 times 6, 216. But see how it would have been easier to substitute it into the previous, original equation. So if we did substitute it into the original one, we would have 6 over 2 cubed, which gives us 6 divided by 2, which is 3. 3 cubed. 3 cubed is 27, and I just realized that I hadn't finished this question off. So 216 divided by 8, and I just have to double check that on the calculator, is 27. Okay, so I think easier using the original rule. Okay, so then you can do for 4 as well. Question D, find the number of days required to germinate 64 seeds and 1 seed. So let's get rid of all that. So I'm just going to rewrite the rule again. So n equals t over 2 cubed And let's just write the question. So D part I, we want n equals 64. So we've got 64 equals. Now, let's just do it both ways. Okay, so if we wanted to get rid of this 3, we're basically taking the cubed root. Okay, so just as the square root is the opposite of squaring, the opposite of cubing something is taking the cubed root. So this is something we're not going to do until later in this chapter, so we will do it. And I'll just show you using this rule or using the one we did in part B. So the cubed root is basically saying, well, what number multiplied by itself 3 times gives us 64? Doesn't take long to work it out. So we know 2 cubed is 8, 3 cubed is 27, 4 cubed, so 4 times 4 is 16, and then 16 times 4 gives you 64. So the cubed root of 64 is 2. Sorry, not 2, is 4. And then we get rid of this 2 here by multiplying 2 to both sides. So t is equal to 8. Now, if you wanted to use the other equation that we did in part B, so 64 equals t cubed over 8. So you can multiply both sides by 8, which leaves us with t cubed. Oh, I thought it was going to make things easier, but no, it's not. So we're going to have to do 64 times 8, and I am using my calculator now. 512. Okay, not as I thought it would be easier. So to get rid of that cubed, we're going to take the cubed root of both sides. And we already know the answer is 8, so let's just check. 8 times 8 times 8, does it give us 512? It does. So t equals 8. So using the original formula is a lot easier. And then if it was one seed, you're doing the same thing. I think it's going to be a lot easier to do. Actually, one seed, let me just check. So yeah, you should be fine for 1. All right, question 7, find the value of a that make these equations true. So an a has to be greater than 0. Okay, so let's look at the first one. Equals 4 over 9. Okay, so let's do this squaring first. So a to the power of 2 equals 3 to the power of 2, which is 9. So you can see your denominators are the same. So I'm only working with the numerators. So that means a squared is equal to 4. So what number when multiplied by itself twice gives you 4? It's 2. So you could have also said, well, a is equal to the square root of 4, which is also 2. Okay, could have done it that way. All right, let's have a look at doing a harder one. So I might do E and then I might do F. 2a over 3 squared equals 4 ninths, again, just coincidental. Okay, so the 2, remember, relates to that 2 and the a, so don't forget both of them. So at this point, we've got 2 squared, which is 4a squared over 9. So we want that to be 4 over 9. So we've already got the denominator being 9, and the numerator at this point is 4a squared. So 4a squared equals 4. So you can solve this algebraically if you like, just get a on its own. So divide both sides by 4. So a squared equals 4, and just like we did before, the square root of 4 gives you 2. All right, let's do F. Twisting my pen around. So 6a over 7 cubed equals 1,728. Okay, so this cubed applies to the 6 and the a and the 7. Oh, sorry, I forgot the, there we go. All right, so we're going to have to expand the 6 and the 7. So 6 cubed, so 6 times 6 times 6. Again, I'm going to just use my calculator. 6 times 6 times 6, 216a cubed, and then 7 cubed. I think we did that before, didn't we? Maybe 343 equals 17 to 8. So you can see if you can simplify this. I would just get rid of that 343. Oh gosh, yeah, you can only use a calculator for this. Unless you rewrote 1728 in index form. So let's get rid of that 343. So let's multiply both sides by 343. So that disappears. So 216a cubed. As I'm doing this, I'm thinking there's probably a better way to do it, but we're going to do it this way. 343. So what have we got? 592,704. So I am using my calculator now. Get rid of that 216. Now I've run out of room on my page, so I'm just going to write over here. Okay, so then we've got 2,744. Now, as I said before, the opposite of cubing something is taking the cubed root, and there's actually a button on your calculator for you to do that. It probably looks something like that. Okay, so you need to tell it the x is 3. So if you press that button, and you can input the 3 for a cubed root. So, oops, I'm using my phone, so I'm just going to have to quickly figure it out. No, I think it might be 14 cubed. Cool. So the cubed root of 2,744 is 14. So not much space there, but hopefully you got there in the end, girls. All right, bye.